When brakes of a car are fully applied, the car will continue to travel some distance before it completely stops. Correct? This stopping distance d is directly proportional to the square of the speed of the car. Correct? Directly measured in meters is directly proportional. So what does this mean? D is directly proportional to the square of the speed of the car. Correct? How do you get rid of the proportionality sign? You put a constant. Where k is the constant of proportionality. When the car is traveling at 50 kilometers per hour, so when the velocity is 50 kilometers per hour, the distance it travels is 12.3 meters. After the brakes are fully applied, before it completely stops. So you substitute this value and get the value of k. Because for the first part, we'll have to get this. So 12.3 k into 50 square. So k is equal to what? 12.3 upon 50 square. Do that on your calculator. Do that on your calculator. That's 0.00492. So that means that your part A, that your D is equal to 0.00492 velocity square, V square. So that's your determine your value of D in terms of V. The police can use this equation to estimate if cars are exceeding the speed limit. A car is found to have traveled 33 meters after fully applying the brakes before it stops. Use the equation to estimate before the speed that a car was traveling.
Okay. Are you ready?
The distance the car is found to travel 33 meters. Means your distance is 33 meters. Correct?
So you solve that.
You have to find V.
Yeah, I did that. 81.8.
So 81.9.
81.89 plus 81.9.
81.9 what? Kilometers per hour. Kilometers per hour. Then, after the brakes have been fully applied, identify other variable besides speed that could be affecting stopping distance. What else?
Length of road.
Length of the road, how will it affect the others?
Because with the road you have to speed, otherwise you will fly.
No, the stopping distance. The reaction time of the driver. Reaction time, the friction between the tires and the road. All that will. A rectangular box with open top is to be constructed from a piece of cardboard that measures 48 centimeters by 30 centimeters. So this is 48. This from here to here is 48. Correct? And this is 30. Square of equal sizes. So these squares have been removed. Squares of equal sizes are cut from the corners of the. So all the 4 squares have been cut from the cardboard. And you folding it along the dotted line. The volume of the box in centimeter cube can be modeled by the function Vx is equal to 48 minus 2x, 30 minus 2x, x. For this domain, 0 is less than x is less than k, where x is the length of the side of the square removed in centimeters. X is the length of the side of the square removed. Write on the maximum possible value of k. So what is the maximum possible value of k?
K.
Now k is the side of the square. See, you can cut off bigger squares also from here.
Maximum value is 30 divided by half, so 15.
15, correct? The maximum will be 15. Correct? So k is equal to 15 because obviously 30 is the smallest side. Yeah. So if you get 15 here, 15 here, so k will be, so maximum possible value is 15. The value of x that maximizes the volume of the box. Use a calculator, graph in the calculator and find max. Okay, so this you put type in the calculator. Now see, if you don't see anything, listen. Now pay attention, this is very important. You have to view window. What's the values of x? 0 to 15. So put 0, put 15, max 15. Enter, enter. See the graph? Correct?
Yeah.
View window. Still you can't see it. Now what you need to do is, even without seeing the graph, you can okay, before that, you can do view window and you can make it standard. So you see a straight line going up. Correct? Okay, then zoom, do zoom auto. You can see that zoom auto. You adjust the window. So this is your 0 to 15. Do zoom auto and move the window. Now you find the value of x which maximizes the volume. G solve max. 6. Correct? So what you have to do in exams, you have to sketch this graph. This graph you have to sketch. 6, 0, 15. Only 0 to 15. Correct? Sorry. 6. This is 6. Correct? So value of x. So x is equal to 6 when the volume is maximum. Okay. Now try the next part. 2 centimeters is removed. See, you have your cardboard originally right now. This is 48 and this is 30. Now what you do is you're removing 2 centimeters from each side. Because it's damaged, you're removing 2 centimeters from each side. So 2, 2, 2, 2 is getting removed from each side. So what is now the new length of the cardboard?
46 or 28.
48 minus 2 minus 2. You're removing from both the sides.
Okay.
So that would be 44. Correct? And this is 30. You're removing 2 and 2 from both the sides. So how much is that?
26.
26. Correct? So 44 and 26. Find the maximum possible volume now.
Now you do the same thing with just
So now what is going to happen is that now the volume will become 44 minus 2x, 26 minus 2x,
you have to make it 15.
and then x.
Maximum.
You do zoom and you do that. No?
Does it have to make it 15? No.
Yeah, it's okay. You can
X
that
is
won't matter.
14.6.
Yeah, no problem.
No, your X. The answer is 14.6.
Answer is 14.6. 44 minus 2x.
I just did zoom out of 40 max.
Yeah.
6.
Correct. G solve max. Max you're finding. No? So 5. The maximum volume is 2726. 27. That's a maximum volume. Maximum, you have to find this where it's maximum.
Yep.
So that's 2726.
I got different value. Check again, sir.
2726.14.
How have you got that?
I just entered the value, no? I just made it 44
I
minus
did the exact same.
44 minus 2x, 26 minus 2x into x, correct? You graph it. G solve.
Yeah.
Go to max.
Yeah.
So 5.28.
No.
Yeah. So she's making 6 more pendulums. So that means that's your D. Your D is equal to 6. She makes 10 pendulums the first day. So that's your U1 is equal to 10. So find the number of pendulums made on the 12th day. So U12 is equal to U1 plus N minus 1 into D. So U1 is 10 plus 11 into 6. 76. So you want a total, whenever total comes in, it's Sn. So for this is Sn is equal to N over 2 in 15 days. So 15 over 2, 2U1, 2 into 10 minus plus N minus 1. That's 15 minus 1 into D. D is 6.
It keeps 6 in the.
If you put this in the calculator, you'll get 780. Okay, so that's your part B. Next part.
15 upon 2 equals 2. Right?
Yeah. So see, again, we want a total of 1000 pendulums. At least 1000 pendulums you want to sell in the market. So that's your SN. So SN is equal to N over 2, 2U1 plus N minus 1 into D. We want to find out how many more she should make every day. Means what's the difference we want. So your SN is at least 1000 we want. So you put 1000 for time being. N, that's 15 upon 2, 15 days. 2U1. On the first day you're making 10 pendulums, so that's 20. Plus 15 minus 1, that's 14. D is your X. So you can put N solve for X. 0.09, but your answer should be 9. Because if you make 8 pendulums, you won't complete your order. You want at least 1000. So you have to exceed 1000. So if you make 9, so your final answer will be 9. The increment should be 9. Then you'll exceed 1000, that's not a problem. Continues. Dinah tests one of a pendulum. She releases the ball at the end of the pendulum to swing freely. The point at which she releases is shown as the initial position. Pay attention, please. Pay attention, please. On the left hand side of the diagram, Dinah begins recording the distance traveled by the ball after it reaches the extreme position. Represented on the right hand side. This is the extreme position. Diagram. On each successive swing, the distance the ball travels is 95% less than the previous swing. So let's see, here they have shown, okay, your first swing is 17.1, the second is 16.245, that's 95% of the previous one. During the second swing, during the first swing she recorded a distance of 17.1, that's from here to here. During the second swing she recorded a distance of 16.245. What is the distance she recorded in the fifth swing?
So you don't need
geometric sequence because 95% of the previous swing. So that means your R is 0.95. Remember, generally in your IB exams, first will be arithmetic, second will be geometry. You can remember that way also. But it's a good way to remember that R is 0.95. What's your U1? 17.1. This is your common ratio 0.95. You have to find the distance traveled in the fifth swing, so U5. So you have to use your formula UN is equal to U1 R raised to N minus 1. So U5 is equal to U1 R raised to 4. 5 minus 1 is 4. So U1 17.1 into 0.95 raised to 4. Work that out. 13.9. So that will be 13.9. So that's your part B. So 13.9 is the distance traveled, centimeter. Then the total distance traveled? SN, yes. The formula of SN is then your formula booklet. U1 1 minus R raised to N upon 1 minus R. Please apply this. So
why is it coming in this thing here?
17.1.
So
1 minus 0.95 raised to 16 upon 1 minus 0.95. So if I use my calculator, R is the percentage, correct? So 191.5. Three significant figures would be 192. So 191.48 if you write. So three figures will be 192 approximately. Your total distance traveled. Part F. Calculate the distance traveled before Dina starts recording. Before she starts recording, this first one, because that we didn't count. No?
It will be plus 0.9.
No, what will you do? 17.1, you will divide by 0.95. Because that it will be a higher value when you divide it by a smaller number, the value will be. Here it's given